Okay, we're going to design a schematic diagram and a PCB using Eagle software. Okay, today we're going to create a frequency halfer, or it halves the frequency of your AC input signal. It works for audio effects pedals and such. So right now, please open your Eagle and file, new, schematic. Right here, you're going to use the add function to add your components. Well, you can look up your components right here to your left. It offers a lot of them. Although not all of them, you could create your own, but this will just place an introduction how to add. Just select your component. You can see to the right the physical attributes of that component once it's in a PCB form. To the left of that image is a schematic symbol. So here we're going to place diodes, potentiometers, and connectors just for the sake of creating a circuit. Okay, once you're done adding, don't forget to also add the ground of your circuit and a voltage source if needed. Right here I'm dealing with only signals, and that's good. And also for the components, you could rotate them, you could mirror them, you could delete, and you can do anything you like, except they're not in 3D form. The schematic diagram is only good for 2D. And by the way, Eagle is not a simulation software, so it doesn't simulate the circuit. It only creates a schematic diagram so that it will be translated later in PCB form. So it's very tedious if you just create these diagrams out of nothing and then it can't be simulated, so you have to use another simulation software and create another diagram for that purpose. So I guess that's a very bad part about this software. It doesn't simulate it, but it's good. Okay, once you're almost done, double check each connection to the components and each connection to GND or the ground. If they're okay, you can switch to PCB or switch to board, and then click yes, and you can see a black screen with a white rectangle, which you can modify to resize your PCB. Okay, once it's good, you can place the components strategically on the PCB. Strategically because it is very difficult to place the components or to connect them using copper traces if they are in a very bad arrangement. So you'll make a hunch what's the best arrangement. There will be yellow lines that signify the connection should be in that manner. And once you're good, you can click ratsnest to shorten or make a possible computation of the shortest connections or the shortest routes. And once you're done with that, you can click drill holes so that you won't forget them in case you need to drill it on a surface or to place a PCB on a surface using a screw. Now you can use a route function. Click one pin and then follow the yellow line. That yellow line is your guide to where that pin should be connected. And by the way, I use a kind of a bent wiring in PCB so that I don't know, it's my style. I don't like in full 90-degree copper trace. I want it to be bent. Oops, you can see that I overlapped that drill hole. So it's okay to overlap a drill hole as long as you don't overlap another copper trace wire or another wire in that case. You could place text so that for the sake of it. Once you're done with that, you must place a copper. Well, I'm just going to extend it for a bit. I'm going to move it to the center. The crosshair is the center of the paper. I'm going to print it on a 8.5 by 11 inch paper later on. And now, let's double check. Let's go to the schematic. Double check that the GND or the ground is well connected. And I'm going to rename it to GND, which is GND, of course. So, make a polygon, solid polygon with spacing of 0.05 and isolation of 0.012, and then trace the whole PCB. And you could double check the name, rename it to GND, and then click ratsnest. That will create a surface or a copper surface that connects all ground connections in your PCB. First, it reduces all the copper that's going to be etched later in the process. Second, it creates a safe boundary for the circuit. In case it has a radio signal or EMF, it will directly go to the ground, so it won't affect other parts of the circuit. It's a good practice. And print directly from Eagle. Don't use any other software in printing, so that it will maximize the resolution. And that's all in making your PCBs using Eagle software.